Hi, this is section 1.2. 1.2 is about Gauss-Jordan elimination. What you'll find is we have a systematic way for reducing a matrix, specifically an augmented matrix, so that we can find the solution to a system of equations. Let's take a look at Gauss-Jordan elimination. All right, the first thing we need are the legal elementary row operations. There are basically an infinite number of illegal ones, but there are three that are legal. And those are, first, you could multiply a row by a non-zero constant. Any number other than 0. For example, if I had 2r1, I would want to multiply the entire row 1 by 2. And you'll notice the notation for rows is just r1, r2, r3, and so on. We use subscripts to denote separate rows. So 2r1 would multiply every entry in the first row of a matrix by 2. Okay, another of the elementary row operations is you can switch two rows. I can actually take the elements, for example, that are in row 1 and switch them with the elements in row 2. So I would interchange, if I had R1 switch with R2, that would interchange the elements in the first and second rows. All right. The other legal elementary row operation is you can add a multiple of one row to another row. Now let that one sink in a little bit. Add a multiple of one row to another row. All right, the notation for this is, for example, if I had R1 plus 2R2, what that means is I want to multiply row 2 temporarily by 2, then add it to the elements in row 1. All right, so I'm going to take the elements in row 2, temporarily multiply them by 2, and then add that to row 1. Now row 1 is actually the one that's going to change in that case. R1 plus 2R2 would add twice the elements in the second row to the elements in the first row. Note that the row that is written first is the one that changes. So because I wrote R1 plus 2R2, R1 is the one that changes. Okay, the change to R2, multiplying it by 2, that's just a temporary change. And you'll see some examples of these as we do some problems. All right, now Gauss-Jordan elimination is made up of any combination of these row operations. I might want to use that first one that we looked at where you could multiply any row by a non-zero constant. I might want to use that one several times, or I might need to use the second and the third a few times and never touch the first one. So I could pick out any combination of those. I might use one step more than once. I might use one of them not at all. But what we're going to try to do, of course, depends upon the matrix that we're looking at. Our goal is going to be to get 1, 0, and then like an A, and then 0, 1, and then like a B. And the A would be the solution to x1, and B would be the solution to x2. Or if I were dealing with a 3 by 3 system, I'd be trying to get 1, 0, 0, and then some number. I'm just calling it x. And then 0, 1, 0, and then some number I'm calling y, and then 0, 0, 1, and then some other number z. All right, so the reason that this is going to be nice for us is because if you look at this equation that's circled, that says 1x1 plus 0x2 is equal to a. In other words, x1 is a. And then the next one, that says x2 is b. In the 3 by 3 system, that one is telling me that x1 is x. Well, the number x, whatever the number x happens to be. Then this one is telling me that x2 is y, whatever that particular number is. And then the last one tells me that x3 would be whatever the number z is. Okay, so this is why I want to get to an end process that looks like this. Makes finding my solution very quick. Use Gauss-Jordan elimination to solve this system. Suppose we have x1 plus 2x2 is equal to 5, and then we have 3x1 minus 4x2 is equal to negative 5. All right, I want to begin by finding the augmented matrix. and this was a 2 by 2 system. All right, so I have 1, 2, 5. Those were the numbers, the coefficients on the left, and then the constant on the right for the first equation. And then the 3, -4, -5. That's the coefficients on the left, and then the constant that was on the right of the second equation. All right. According to what I was trying to accomplish, I want the stuff on the left to look a specific way. Now, as I change the numbers on the left, the coefficients on the left, the numbers on the right are also going to change. All right, so I want to approach this systematically. I don't know if you've ever been working with a Rubik's Cube, and you get, say, the yellow side to look perfect. And then as you go to work on the blue side, you mess up the yellow side. We don't want to do that. So that's why we're going to have a systematic way of approaching this. We want to go in an order so that we don't undo something we worked really hard to do. All right, so that's why I'm going to go in a specific order each time I do a problem. All right, now I want to use the elementary row operations to make it look like 1, 0, and then some number. This time I'm just calling it R, and then 0, 1, and then some number I'm just calling S. All right. I always want to start in a 2 by 2 system with the upper left-hand corner, which is the 1, 1 entry, because it's in row 1 and column 1. As you see right there, that already is a 1. That's a good sign. That means I don't have to do anything for that one to make that one look right. Okay, now you're going to go column by column. So after I get that first position to look the way I want it to in the first column, then I go down to the next entry in the column. So I next want to move to the 3. All right, so I've got the first column to be 1, and then I want a 0 where the 3 is. All right, the way I'm going to accomplish that is to use the 1 that's above it. Now I can't just say, like, 3 minus 3. I can't just subtract a number, but I could subtract 3 times 1, and 3 times 1, the one that's located above it, would give me the 3 that I need to subtract. So if I'll do row 2 minus 3 times row 1, that's going to give me a 0 in that position. All right, now I just wrote out this step. Some people like to write this out, some people don't. But initially, when you're beginning all this stuff, it might be a big help to you. I just wrote, hey, we want to do row 2 minus 3 row 1. So let me write out row 2. Row 2 was 3, -4, -5. -3 row 1, in other words, minus 3 row 1. I want to just take row 1 and multiply it by -3. That gives me -3, -6, -15. Now if you add those two rows, you'll be left with what goes in place of row 2. So the 0, the -10, and the -20 is your new row 2. Okay, so if you now look at row 2, what was originally there has been replaced with 0, -10, -20. All right, remember we said whatever is written first in the expression is what gets to change. So the row 2 was written first, so it's what's going to change. All right, next. The first column looks good, so now I can move to the second column. All right, in the second column, you always want to start with the place that you want a 1, and I want a 1 where the -10 is. Okay, now the only way you can get a -10 to be a 1 is if you multiply it by its reciprocal. All right, so I want that -10 to be a 1. Its reciprocal is -1/10. So what I would want to do now is to do -1/10 of row 2. -1/10 of row 2 is going to give me a 1 in that position where I used to have a -10. Okay, and as you see, the -20 also changed from the previous slide into a 2. All right, so I've got the second column started. I just have one more entry that I need to fix, and it's that 2 up there. The 2 is in the 1, 2 position, it's called, because it's in the first row, second column. All right, I want that 2 to be a 0. And the way that I can get a 2 to be a 0, I can't multiply by 0. That's not a legal elementary row operation. What I can try to do, though, is to somehow subtract 2 from that. Now, I can't just subtract the number 2, but I can subtract 2 times the 1 that's below it Okay, that's why I go for the 1 first, is because it helps me get the 0 in the rest of the column. So if I'll do row 1 minus 2 times row 2, okay, you'll notice 2 times row 2, that's going to give me a minus 2 right there. Okay, so I'll wind up just doing 2 minus 2, and that'll give me a 0 where I need 1. Okay, again, I wrote out the step. Row 1 was 1, 2, 5. Negative 2 row 2 is 0, negative 2, negative 4, and then just add, because subtracting, of course, is like adding a negative. And it did say that one of our legal elementary row operations was to add a multiple of one row to another, so adding a negative multiple is like subtracting. Anyway, I got 1, 0, and 1. So that's what's going to go in place of whatever was written first, which is row 1. All right, so in the row 1 position now I have 1, 0, 1. I already had the 0, 1, 2 in the second row. And as you see, I now have it in that form that I wanted. The left side looks like what I wanted. On the right-hand side, those are my solutions. So x1 is 1, x2 is 2. Okay, now I can always check myself. It's not a bad idea if you have the time to go ahead and check. Plug in the 1 for x1, plug in the 2 for x2, and you'll find that you get 1 plus 2 times 2. Yes, that is equal to 5. And then 3 times 1 minus 4 times 2, yes, that is negative 5. Okay, now that's not a guarantee on all problems that it's the only solution. There may be more solutions on some problems. In this case, it's the only solution, but this will always indicate whether or not it is a solution to start with. But there still could be more on some problems. That's coming up in about section 1.4 or 1.3, so keep your eyes open for that. All right, notice I did go in a specific order. We will always go in this order with the 2x2 system. If you don't, like I said, you're going to mess up something you've already done. So I want to start with that a sub 1, 1 as I've written there. I want that to be a 1. Okay, so maybe you're going to need to switch a couple rows. Maybe you're going to need to multiply by a certain number. You could also possibly add a multiple of another row to it to get it to be a 1. So how you get it to be a 1 is your choice, as long as you're operating within the legal elementary row operations. So once you get it to be a 1, though, that's probably going to change the other two entries in the row. So you'll see that what I did on the next slide was I just put some quotes there, okay, because I don't really know what they're going to be. I just know that I'm going to have a 1 in the 1, 1 position. All right, next, I want to attack the next entry in the column, because remember we go column by column. So I want the a sub 2, 1 to be a 0. Okay, now luckily I can use the 1 that's right above it and just do whatever the number a sub 2, 1, whatever that happens to be, just subtract that same number times the 1 above it. So that same number times row 1. And what that's going to do for me is give me a 0 right there. Now in the process, it's going to give me some other entries in the rest of that row. Okay, so I don't really know what's in the rest of that row. That's why I just put some dots or some quotes again. Okay, but after I get the first column looking good, then I move to the second column, and I move to the position where I want a 1. Usually a good way to get a 1 right there is to multiply by its reciprocal, because it said we could multiply by a non-zero constant. So that's a good way to get a 1 right there. Once you get a 1 there, then you can use it to get a 0 in the position above it. Okay, so once I have a 1 there, then I'm going to try to get a 0 above it. And like I said, this is going to change the numbers that are over on the right. Okay, but once I get to this point, it's really easy to say, oh, my solution is just whatever happens to be in that column. The first number, of course, would be the x1. The second number would be the x2. Okay. So that's going to keep us from undoing things that we just did. All right, another example, solve by using Gauss-Jordan elimination. I've given you another 2x2 system here. You have 2x1 minus 4x2 is equal to negative 16, and then negative 3x1 minus x2 is equal to 3. All right, remember how we want to start. We want to put it into an augmented matrix. And then we're going to go about this systematically. Now you see where the 2 is. I actually want that to be a 1. This is a good one for you to multiply by its reciprocal. Okay, if you'll multiply that whole row by 1/2, then your 2 is going to become a 1. And it's going to change all the other entries in the row as well. So in the first row now I have 1, -2, -8. Okay, after that position looks good, then I move down to where the -3 is. I want the -3 to be a 0. So if we'll add, I say add because I had a -3. You can think of it as subtracting a -3 times whatever. But I want to add 3 times row 1 to that, because that's going to give me a 0 right there. Now you notice if I'm working in column 1, I'm using row 1. Working in column 1, you use row 1. Wonder if that's a coincidence. We'll have to check it out later. All right, so that's going to fix the -3. It's going to make it a 0. It's also going to change the other entries in the row, because I now have a -7 where I used to have a -1. That's because if I take -1 and I add 3 times -2 to it, I'm adding -6 to it. -1 plus -6 is -7. And then for the 3 that was up in the first matrix, if I were to multiply the -8 by 3, that gives me a lot. -8 by 3, and then add it to the 3, I get -24 plus 3, which is -21. All right, next I want to move to the -7, and I want that -7 to be a 1. So again, a reciprocal is a good way to go on this. If you'll do -1/7 of row 2, that's going to give you 0, 1, 3 in the second row. All right, and last, I want to get rid of the -2. Notice I'm in column 2. I have a 1 just below it in row 2. Column 2, use row 2. Again, there's that same kind of pattern. So I want to do row 1. Remember, I want to change row 1, so I put it first, plus 2 times row 2. Okay, and if you'll do row 1 plus 2 times row 2, that's going to give you a 0 in that position. It's also going to change the -8. It's not going to be a -8 anymore. It's going to be a -2, because I want to go 2 times the 3 and add that to the -8. That's how I get a -2 up there. All right, so once I get it to this type of appearance, then I'm ready to write down what x1 and x2 are. x1 is -2, x2 is 3. Okay, so there was our systematic way of solving a 2 by 2. Let's see what is the same and what is different about solving a 3 by 3. Let's use Gauss-Jordan elimination to solve 2x2 minus x3 is equal to 1, 3x1 plus 11x2 is equal to 1 plus 5x3, and then 3x2 minus x3 equals 1 minus x1. Okay, you probably have already noticed this is not in standard form. And I'm supposed to, first step, put this into an augmented matrix. So a good step to make before I try to go for the augmented matrix is to get it in standard form. All right, so first get that into standard form. And you can see all I did was I slid all the variables over on the left, the constants over on the right. I also put the variables in order so that I had x1, then x2, then x3. In that first equation, you may even want to take the step where you say it's 0x1 plus 2x2 minus x3 equals 1. You know, that might help you too when you're putting it into an augmented matrix. Okay, next. I get 0, 2, -1, 1 as the first row of my augmented matrix. Then 3, 11, -5, 1 as the second row. The third row is 1, 3, -1, 1. Okay, now looking at that augmented matrix. What I did when I had a 2 by 2 was I started in the upper left-hand corner. No difference here. You want to start where the 0 is. You want to start in the 1, 1 position. What do I want there? I want a 1. So I don't want a 0, I want a 1. The easiest way to get a 1 right there is, well, if you look down in row 3, there's a 1. sitting right there. So if you'll actually do row 1 switch with row 3, that's going to interchange those two rows, giving you a 1 where you need a 1, and actually it's going to give you a 0 in this case where you need a 0. So it's going to be pretty efficient. Excuse me. All right, so I've got a 1 now in the 1, 1 position. Next, I move to where the 3 is. Okay, in the second row, I don't want a 3, I want a 0. Okay, so I'm attacking the first column. I'm actually going to do the whole first column on this one. Okay, with a 2 by 2, the first column only contained 2 entries. Okay, with a 3 by 3, obviously I have 3 entries in the first column. So I want to get a 0 where the 3 is. The way I'm going to do that is to use row 1. There's that pattern again. I'm in column 1, I'm using row 1. All right, so I do row 2. You'll see you had a positive 3, so I did a minus 3 times row 1. What that's going to do for me is it's going to give me a 0 where the 3 is, and then where the 11 was, I get a 2, and so on. Okay, so now row 2 has a 0 where I needed it to have a 0. All right, row 3. You'll notice, hey, there's already a 0 there. Yay, I don't have to do any work to get that one there. Okay, so I can move on to something else. And what you want to move on to is the second column. Now you always start with the place where you want a 1. And I want a 1 right there, where the 2 is. So the 2, 2 position, I want that to be a 1. A great way to get a 1 right there is to multiply by its reciprocal. So multiply by a half. If you'll do half of row 2, that gives you 0, 1, negative 1, negative 1 in row 2. Okay, once you've gotten the 1, you can move on to the other 2 positions in the column. Now it doesn't actually matter. Once you get the 1, that's really important. But it doesn't matter now if you are looking at the second column, if you get rid of the 3 or the 2 next. Okay, so I just chose to get rid of the 3. I want to change row 1, and I want to use row 2 to do it because I'm in column 2. So row 1 minus 3 row 2 is going to do that for you. And you can see now in row 1 I have 1, 0, 2, 4. Okay, now next, in that same second column, I still have a 2 where I need a 0. So if you will do row 3 minus 2 row 2, that's going to give me a 0 where the 2 is. Okay, and you can see, again, it's changed the other entries as well. All right, so it's looking pretty good. First column looks great, second column looks great. Let's move to the third column. In the third column, where do I want a 1? Because that's where I always start. I always start with the place I want a 1. I want it right there. Well, hey, check it out. There it is already. So I don't have to do any work to get my 1. Had that been like a 2 or something, I'd probably want to think about multiplying by the reciprocal. If you try to do a different type of step other than multiplying by the reciprocal, you're going to mess up your zeros at the beginning to get that whole Rubik's Cube situation. Okay, so I've got a 1. I don't want to do anything to mess it up. I'm just going to now move up to where I have the 2 in the first row. I want that to be a 0. Now you notice I'm in the third column, so I'm going to use the third row. Row 1 minus 2 row 3. Okay, I do minus 2 because I had a positive 2. Row 3 is where that 1 is sitting, so I'm doing 2 minus 2 times 1. And you'll see that changes your 4 also to a negative 2. One last step, and it's where the negative 1 is. I want the negative 1 to be a 0. Okay, so if you will use the positive 1 that's right below it, in other words, multiply the positive 1 by 1, and add it to row 2, row 2 plus row 3. Remember, I'm changing row 2, so I write row 2 first. That's going to give me a 0 there. It's also going to give me a positive 2 as the last entry in the second row. All right, so now I finally have this thing in the form that I want. And I'm able to write down the solution, which is x1 is equal to negative 2, x2 is equal to positive 2, and x3 is equal to 3. Okay, remember, if you have the time, check yourself. So let's just check this into the original equations and see if I get something that I really believe. Is 2 times 2 minus 3 equal to 1? Yes. Is 3 times negative 2, which is negative 6, plus 22 equal to 1 plus 15? Yes. What about 3 times 2 minus 3 equals 1 minus negative 2? That also is true. Did I need to check all three? Yes, I did, because it is quite possible that you'll find some numbers that work in the first two that don't work in the third one. Excuse me, or you might find some numbers that work in the last two that don't work in the first one. So you really do need to check into all three. Okay, so that was section 1.2. As you saw, Gauss-Jordan elimination is made up of a sequence of normalize and eliminate steps. By normalize, I mean you want to get a 1 in the correct position for the particular column that you're working in. Then you want to use that 1 to eliminate, in other words, get zeros, in the other positions in the column. Give this one some practice. This one should go fine. It is an extremely important section because we're going to use this material, this information, for the rest of the semester. So make sure you have this one going really well for you.